Okay, my dear friends, this is the year October November 19, paper 6, variant 1, and we are solving the second half of this question, starting from question 3. A student investigates the cooling of water. The thermometer in figure 3.1 shows the room temperature theta R. Room temperature theta R at the beginning of this experiment, record theta R. So see 20, 21, 22, 23, 24, 24. So 20, writing only 24 will give you 0 marks. Unit, you can check here on the scale, that is degree Celsius. So first mark you have scored. The student pours 200 centimeter cube of hot water into a beaker. He places the thermometer in the water. He measures the temperature theta of the hot water in the beaker. He immediately starts the stop clock and continues recording the temperature of the every temperature of water every 60 seconds. The temperature readings are shown in the table. Now complete the time column in the table. Time column in the table. What to do? Every 60 seconds. So 0 plus 60, 60. 60 plus 60, that is 120. 120 plus 60, that is 180. 180 plus 60, it will be 240. Then be very careful. Sometime 60 seconds, sometime 30 seconds, rarely half a minute. Every half a minute. Then here unit right now half a minute, so then you will be writing either 0, 30, 60, 90, so on. If the unit here is seconds, here it is seconds. So if it was half a minute, here right now it is every minute. But if it will be written here already minute, then 0 you will write for 30.5, for 60 you will write 1, and so on. I have discussed already that question with you. So complete the column headings in the table. So time is in seconds and temperature is in degree Celsius. You know what I mean to say? Like there can be the time column here, theta in degree Celsius, here time is in seconds. If the examiner is saying every 30 seconds, so then it will be 0, like 95, then 30, 60, 90, 120, and so on. But if the time is already mentioned here in minutes, and theta in degree Celsius, starting temperature is still 95, and then he's saying every 30 second even, or every half a minute, so then how to write here? It will be 0, sorry, first of all it is 0, then 0 0.5, then 1.0 because it is in minutes, then 1.5, it means 90 seconds, then 2.0, it means 120 seconds, and so on. So be very careful about these column headings, and definitely whenever this thermal question is there, column headings are involved into the question. So we have done the complete column headings, and also we have completed the time column. Then calculate the decrease in temperature delta theta 1 during the first 120 seconds. So it means we have to calculate in the first 120 seconds. How to calculate? That is 95 minus 85, which is equal to 10. So we will be writing here 10 degrees Celsius. 10 degrees Celsius. Calculate the decrease in temperature delta theta 2 during the last 120 seconds. So up to here. So then, my dear friend, it will be 85 minus 78. So it will be equal to simply 7. So it means 7.0 degrees Celsius. Am I right? Yeah, it is 70. So very simple. Just follow the instructions and keep on scoring the grades. Next is now tick the box to show your conclusion from the results in C, that in first 120 second temperature fall was 10 degrees Celsius, and in the last 120 second temperature fall was 7 degrees Celsius. So of course in the beginning average rate of cooling was greater, and in the end average rate of cooling was smaller. So so what are these here? statements here. The average rate of cooling is greater in first 120 seconds than the average rate of cooling in the last 120 seconds. Yes, it looks correct. Average rate of cooling is less. This is wrong. Average rate of cooling is same. This is also wrong. So we will take in the first one. Now justify your conclusion in D1 by reference to the results. So my dear friend, reference to the results, then you have to give the numerical value. And how we will write? See, you will say that the delta theta 1, it was delta theta 1, that is equal to 85, sorry, 95 minus 85, which is equal to 10 degrees Celsius. This said rate of cooling, so I can write even delta theta 1 over T. It means over 120. So here also you can write 120 seconds. So answer will be 10 divided by 120. So answer is 0.083. 0.083 degrees Celsius per second was the fall of temperature. Then for the second half, delta theta 2 over T, this is 85 minus 78, again over 120, so it is 7 over 120. So my dear friend, it will be very less, 7 divided by 120, so 0.058. 0.058 degrees Celsius per second. So rate of cooling is decreased when it is mentioned by reference to the results. So please this way. Even if you have written 10 degrees Celsius and 7 degrees Celsius, that will be workable, but it is better because it is written rate of cooling. So rate of cooling means time is involved and time is in denominator. Now he's saying suggest two ways in which the student could reduce the rate of loss of thermal energy from the beaker in this type of experiment. Very simple. He can put a lid at the top of the beaker. Cover the beaker with a lid. So when there will be a lid at the surface of the beaker, at the top of the beaker, to the rate of heat losses, thermal energy loss to the surroundings will be reduced. Thermal energy loss to the surroundings will be reduced by convection and radiation. Another thing, smaller surface area. Use a beaker with smaller surface area. What will happen? Because when the surface area will be less, so rate of cooling will be less due to evaporation. So these two, even you can use a smaller volume of water. You can use high room temperature, because when high room temperature will be there, then difference of temperature between hot water and room temperature will be smaller, so rate of cooling will be less. So many even insulate the beaker, that can be written. So I have written these two, and I have explained you why this is correct. Then next is draw a diagram of a measuring cylinder being used to determine the volume of water. Show clearly the water level and draw with a ruler a straight line showing the line of sight required to obtain an accurate reading of the volume of water. So no problem, let's draw it roughly this way. This is a measuring cylinder, top and centimeter cube, and we can go with the labeling this way. And then my dear friend, we can make the surface of water like this, and then with the help of a ruler we need to draw the line of sight. and a line of sight is always from the lower level of meniscus, and it should be perpendicular to the beaker. So this way you can liquid or water level. Okay, so that is the water inside here, so you can show something this way. So that is the question based on thermal physics. Please, if there is any question or query, feel free, you people can ask me. But very important, when it is written by the reference of to the results, then it means the reference to the results mean you have to show some numerical data. You have to show some numerical data. Now, a student is investigating the time taken for metal ball to stop moving after being released on a curved track. So it will keep on oscillating, and every time oscillation will keep on decreasing, and ultimately it will come to rest like this. So figure 4.1 shows the shape of the track. The track is flexible, so the shape of the curve can be changed. The following apparatus is available: a selection of metal balls of different masses, a flexible track, clamp to hold the track, a stopwatch to measure the time, tape measure, a meter rule. So the student can use other apparatus and material which are usually available in the school laboratory. So plan an experiment to investigate a factor that affects the time taken. I will choose the height of the ball or height of the release. Time taken for a metal ball to stop moving after being released on the curved track. So what I will do, like I can keep this track same, but I can see, let's suppose first I am rolling the ball from here. So this is the height of the ball. Then I can roll it from here. Now this is the second value for the height of the ball. Then I can roll it from here. Then like this. So as the heights will become, different heights will be there. So the time taken for this ball to come to rest, it will be different. So my dear friends, height is independent variable, because this is changed by Ahmad Abdu. Gasim, independent variable. Time taken, that is dependent, because it will depend on height. Dependent. That is a dependent variable. Now, in your plan, you should state how you would expect the ball to move. How would you expect the ball to move? So, of course, the ball will keep on oscillating. The ball will keep on moving back and forth. The ball will keep on moving backward, back and forth. Ball will keep on moving back and forth. And instead of moving, I can write oscillate. Keep on oscillating back and forth like a pendulum. Like a pendulum. So this is the first point which we need to discuss. Then explain how you would carry out the investigation. Okay. Release the ball from a certain measured height. measured height, certain measured height and record the time or measure the time until the ball is stopped. Until the ball is stopped. Until the ball is stopped. Then we are always repeating and repeating with independent variable. So repeat the same method. Repeat the same method by releasing the ball from different measured heights. Measured heights are known heights, anything you can say. Heights. So this is the method which we need to follow to get this one. Then what is the next point? State, explain which variable you would keep constant and which variable you will change. So that I already explained up there. So we will keep, okay, wait, I will tell you. So we will keep the mass of the ball constant. We will keep the angle of the ball constant, angle of the track constant, and which variable you change. What did I say? Keep the constant. Yeah, mass of the ball will be kept constant and the height of the ball will be changed. Okay, I should write it. Because so the next point is mass of the ball is kept constant and height of the ball is changed during the experiment. Okay, then my dear, the next is okay, now draw a table or tables with column headings to show how you would display your readings. You are not so, of course we will go with, in the column headings we will be going with the height, in you can take millimeters or centimeters, and time to stop, that is in seconds, and don't forget to write the unit. So let's write the height in centimeters, and then last will be that how you would use your readings to reach a conclusion. Alhamdulillah. So the last one will be plot a graph of height against time, this one, and then you can write, even if you want to write that, take at least 5 sets of data. So wait, let me check out the marks. 1, this is 2, then 3, 4, and method 2 marks. Yeah, okay, then something we have changed also on the graph also, so it's okay, that's enough. Or you can say repeat and take at least 5 sets of data, so that way you can proceed. Okay, let me write that one also. that take at least 5 sets of data. Why at least 5 sets of data? Because we are going to plot a graph of these values. Okay, my dear friends, if you have any question regarding this or query, please feel free, you can ask me. So question is this in front of you, and all points we have discussed, and I have written it in paragraph, just following those key points given by the examiner. Okay, my dear friends, stay blessed.